Now in this case, the completing the square was relatively easy because the coefficient of x squared was 1. What if the coefficient of the square term is a number other than 1? Well, we first of all have to factor out that leading coefficient. So in this particular case, I'm going to rewrite f of x, take out the negative 2, and write x squared. Now, if I take out negative 2 from the positive 4, I'm going to have a negative 2x. I'm going to put a plus blank, and the plus 1 is going to be on the outside. Now what am I going to add in the blank to make this a perfect square? Focus in on the parentheses. Take half of negative 2, which is negative 1, square that number, you're going to get plus 1. So you're going to put plus 1 in there. Now another problem, we just subtracted 1 on the outside, but here we have a different problem. If you notice here, that 1 has to be multiplied by negative 2. So that by adding the 1 on the inside, we really added a negative 2 to the right side. So we must compensate for that action. Compensating by adding negative 2, we're going to add plus 2 on the outside. So now we haven't done anything to change the problem. The problem is now in the original form. Now this parentheses is a perfect square, and we can rewrite this as negative 2 times x minus 1 squared plus 3. So now we have the problem in the standard form. We have a times x minus h squared plus k, where the vertex is h and k. Now the h value is going to be the 1, and the k value is going to be the 3. Now in this case, a is going to be negative 2. So that means the parabola will open down. So starting with the vertex at 1, 3, we're going to graph that point right here. 1, 3. Now let's draw a horizontal line through that point, vertical line through that point, and now we're going to go down. Because it's negative 2, it's going to be a parabola which is twice as skinny as an ordinary parabola. So we're going to go over 1 and down 2. We're going to go over 1 and down 2. And that should be enough points to give a general shape. So we're just going to connect the dots with a smooth curve as best as we can. That will be my parabola. Now here's another example for us to do. We're going to do this example two different ways. Here we have a quadratic function, negative 4x squared plus 8x minus 1. We want to find the vertex, find the line of symmetry, find the x-intercepts, the y-intercept, domain, range, and then we're going to sketch the graph, labeling key features on the graph. So let's start up here. We're going to complete the square again. So I'm going to rewrite negative 4, factor out the negative 4, we'll have x squared. Negative 4 factored out from positive 8 gives me negative 2x. And then we're going to put plus blank and close off my parentheses. We're going to leave the negative 1 on the outside of the parentheses. Okay, now what thing do we have to add? Again, we take half of negative 2, negative 1, add it, or square it first and add it, get plus 1. Now once again, by putting that 1 inside the parentheses, we got to remember that 1 has to be multiplied by the negative 4. So we really have negative 4 here. So we added negative 4 to the right. To compensate that, for that, we're going to have to add plus 4 as well. So we added negative 4 and added positive 4 on the right side only, so the equation is unchanged. This can now be written as negative 4 times x. We bring down the sign of the middle term, minus 1 squared and plus 3. So now to sketch this, we'll draw a rough sketch here on the right side. First of all, we'll locate the vertex. The vertex is located at 1 and positive 3. Now this parabola opens which way? Down. So starting from the vertex, it's going to be 4 times as skinnier as a normal parabola. So in the normal parabola, if it was opening down, it would go over 1, down 1. But now because the coefficient is negative 4, it's going to go over 1 and down 4. It's going to be over 1 and down 4. Now the line drawn through the vertex, this vertical line, is called the line of symmetry, LOS. Not the line of scrimmage, the line of symmetry. So we have x is equal to 1 is the line of symmetry. That means that the parabola, when we fold it along the line of symmetry, the graph should coincide with itself. Now these 3 points can now be connected with a smooth curve. But before you do so, let's find the x-intercepts. Now the x-intercepts are the place on the x-axis where the curve crosses the x-axis. And the x-intercepts are determined by letting y equal to 0. So if we want to find the x-intercepts, we have to say f of x is equal to 0. So let's take a look at our f of x function. We have 0 equals negative 4 times x minus 1 squared plus 3. Now normally we'd have to square that out and do all that business of trying to find x, but notice that we already have a perfect square. So I'm just going to isolate the x minus 1 squared term. I'm going to put the 4 on the other side and rewrite this as 4 times x minus 1 squared is equal to positive 3. I'm going to divide by 4, so I have x minus 1 squared is equal to 3 divided by 4. Then I'm going to take the square root of both sides of the equation. And when I take the square root, I must take plus or minus. The square root of 3, square root of 4 is 2. So x minus 1 equals plus or minus root 3 over 2. So x is going to be 1 plus or minus the square root of 3 over 2. Now we can rewrite this as one single fraction by rewriting 1 as 2 over 2 plus or minus root 3 over 2. So then we can rewrite this as 2 plus or minus root 3 all over 2. This corresponds to 2 answers. The first x-intercept can be written as 2 plus the square root of 3 over 2, and the second x-intercept can be written as 2 minus the square root of 3 over 2.